and welcome back to the course of Basic Electrical Engineering. In this video lecture, I am going to continue with the unit 2, that is AC circuit. The topic that I am going to discuss in this video lecture is AC analysis of series RC circuit. In the previous video lecture of AC circuit, I have already discussed about the analysis of purely resistive circuit, purely inductive circuit and purely capacitive circuit, as well as analysis of series RL circuit. So let us start with the analysis of series RC circuit. Why the circuit is known as a series RC circuit? So as the name suggests, circuit consists of two components, resistor and capacitor. You can see both are connected in series. There is an end-to-end connection, so both are in series, and across this series combination one AC voltage source V is applied, and because of the AC voltage source instantaneous current will start to flow, which is represented by small I. Now as V is a supply voltage, and according to the Ohm's law, as current is flowing through resistor and capacitor, there is a potential difference across resistor and capacitor. So VR is a potential difference across the resistance, which is given by I into R. VC is a potential difference across the capacitor, which is given by I into XC, where XC is a capacitive reactance and F is a supply frequency, which is measured in terms of hertz. Now we know omega can be represented by 2 pi f, where omega is a angular frequency and F is nothing but the supply frequency. Now both resistor and capacitor are connected in series, then same current will flow from through both the elements, because there is only one path for the flow of current. And as current is common for resistor and capacitor, so whenever we are drawing the phasor diagram, we will be taking current as a reference quantity. Now moving towards the phasor diagram of series RC circuit. As circuit consists of two elements, there will be three quantities: current, VR and VC. So we need to take one quantity as a reference. Now current is common for both resistor and capacitor, so current will be taken as a reference. So current is taken as a reference line, reference phasor. We know the alternating quantity is represented by phasor, because whenever there are number of alternating quantity to be represented simultaneously, then representation of alternating quantity in the form of waveform becomes difficult job. So alternating quantities, multiple alternating quantities can be represented in terms of phasor very easily. Now I is taken as a reference. Now we know for resistor, voltage and current are in phase, so VR will be in the same direction as of current. Now we know another element is a capacitor. Now for capacitor, current leads the voltage by 90 degree, or we can say voltage lag behind the current by 90 degree. As current is taken in this direction, voltage will be in downward direction, so this is nothing but the VC. VC is nothing but the IXC. Now we have to find the resultant voltage, that is a supply voltage V, which is phasor sum of VR and VC. So the phase difference between I and VC is 90 degree, because we have taken the purely capacitive circuit. Now taking the projection of VC over here, now we can find out the resultant voltage, that is V. So V will be in this direction, and the phase angle between applied voltage and resulting current is denoted by some angle which is phi. So V is I into Z. Now from the phasor diagram, so this is nothing but the voltage triangular which we are getting over here, VR, VC and V. So from the phasor diagram we can write V, that is a resultant voltage, is a phasor sum of VR and VC. Taking the magnitude of that, so V is equal to square root of, in bracket, VR square plus VC square. Now VR is, we know we have already found the VR. VR is equal to I into R. So V is equal to square root of IR whole square plus VC is nothing but the IXC whole square. Now taking I common from the square root, we can write V is equal to I in bracket R square plus XC square. Now remember the equation, supply voltage equation for RL circuit. In that case, we got V is equal to I into R square plus XL square. Here it is V is equal to I in bracket R square plus XC square. So I can be written as, that is a resulting current, which can be written as V divided by square root of R square plus XC square, where square root of R square plus XC square is nothing but the impedance of the circuit, which is represented by Z. So this is how we can find out the expression of resultant voltage and resultant current from the phasor diagram, as well as we can find out the phase angle between applied voltage and resultant current for the series RC circuit. And the impedance which we are getting for series RC circuit is Z is equal to square root of R square plus XC square. Impedance for series RL circuit that we got in the previous video lecture is Z is equal to square root of R square plus XL square. Now we can write I is equal to V divided by Z. Now let us find the expression for phase angle phi. So to determine the phase angle phi, we have to take the phasor diagram again. Now this triangular is nothing but the voltage triangular, because all sides are represented by voltage VR, VC and V. So from the voltage triangular we can write tan phi is equal to VC divided by VR. VC is equal to I into XC and VR is I into R. So from this expression I gets cancelled out from numerator and denominator. So finally tan phi which we are getting is XC divided by R. So phi is equal to tan inverse XC divided by R. Now using this value of phi we can find out the expression of resulting current. As the circuit consists of capacitor as one element, we know for capacitive circuit current is leading the result applied voltage by some angle phi. So here or you can also see current is leading the applied voltage by some angle phi. So in the final expression of current will be having positive phase angle. So V is equal to Vm sin omega t is the applied voltage. So expression of current becomes I is equal to Im sin omega t plus phi. So for series RC circuit we can say current leads applied voltage by some angle phi, which is in between 0 to pi by 2. Now drawing the waveform of voltage and resulting current from the expression of voltage and current. So expression for series voltage for series RC circuit is Vm sin omega t and that of current is Im sin omega t plus phi. So here V is starting from the origin, as there is a no phase angle in the expression of V. So this is nothing but the Vm sin omega t. One cycle is taken between 0 to pi. Now as the circuit consists of capacitor, current leads the voltage by some angle phi. So current waveform will be drawn in such a way. So here you can say current is leading the applied voltage by some angle phi, because current attains its maximum value before voltage attains its maximum value, and this angle is nothing but the phi. Now finding the expression for instantaneous power and average power. We know instantaneous power P is given by instantaneous voltage into instantaneous current, and we know the expression of voltage. So P is equal to Vm sin omega t and I is Im sin omega t plus phi. Now multiplying and dividing this expression by 2, so we can write P is equal to Vm Im divided by 2 sin omega t into sin omega t plus phi. If we solve this, we can write P is equal to Vm Im divided by 2 in bracket cos phi minus cos 2 omega t plus phi. So instantaneous power consists of two terms. One is a DC term and one is a fluctuating term. So if we solve this, we are getting P is equal to Vm Im divided by 2 into cos phi minus Vm Im divided by 2 cos 2 omega t plus phi. Now this is the constant part because it does not consist of any time variable omega t, and this is a variable part because it consists of 2 omega t terms. Now writing down to determine the average power, again taking the final expression of instantaneous power. So this is the expression which we have got for instantaneous power. This is a constant part and this is a variable part. Now Vm Im divided by 2 cos phi, is constant, as I told you, because there is a no time variable present in this expression. Now Vm Im divided by 2 cos 2 omega t plus phi, which is a variable component because it consists of omega t terms and which varies at twice the supply frequency, because here 2 is present in the multiplication of f. Omega is equal to 2 pi f. Now we know average of cos omega t is 0. Same way, average of cos 2 omega t will be also 0 because it consists of the frequency, double frequency, but no, number of positive and number of negative cycle will be equal. So average becomes 0 of cos 2 omega t, and phi is a phase shift which has nothing to do with the average. So if we take the integration of this term for one cycle, we are getting 0 value. So by putting the value of omega t, we find that average value of the variable component, variable power component over a complete cycle will be 0. If we take the integration of this from 0 to 2 pi and putting the value of omega t, we are getting the 0 value. Now first term is a DC term, constant term, and we know average of constant remains itself. So average power, final average power which we are getting is Vm Im divided by 2 cos phi. Now we can write 2 as a root 2 into root 2. So Vm by root 2 into Im by root 2 cos phi. Now we know Vm by root 2 is nothing but the RMS value. Similarly, Im by root 2 is the RMS value of the current. So we can write Vrms into Irms cos phi, and Vrms and Irms can be represented by capital Vi. So final expression of average power is Vi cos phi. This is the actual power consumed in series RC circuit. Now moving towards the power factor. So we know power factor is a cosine of angle between voltage and resulting current. So to determine the power factor, we have to draw the phasor diagram again, voltage triangular again. Now this is the voltage triangular. So from this voltage triangular we can write cos phi is equal to VR divided by V. So this is nothing but the power factor for series RC circuit, and we know VR is nothing but the IR and V is nothing but the IZ. So final expression of cos phi power factor for series RC circuit is R divided by Z. In bracket we have to write the leading because for series RC circuit current leads the voltage by some angle phi. So this is how we can find out the expression of power factor from the voltage triangular. So cos phi is R divided by Z, where Z is an impedance which can be given by square root of R square plus Xc square. So this is all about the today's video lecture. In this video lecture, I have analyzed the series RC circuit. We found the expression of resulting current. We draw the voltage and current and finally find out the expression of instantaneous power, average power and power factor. Hope you have enjoyed the video. See you soon in the next video of the AC circuit. Thank you for watching.